Now I know it's recording, and I go to a whiteboard. And I want it big. And here's my tools. I want to use a pencil. And right now I want it to be in black. And this takes over for the mouse. So here I am, 3.2. Now they can, guys, I'm giving a demonstration for someone else too while I'm teaching you. So they can see me, they can see what's going on, and they can hear me. All right, we are going to start with 3.2, which is finding the slope of a line. Okay? Now, slope is always referred to as the letter M. I don't know why it's not S. I can't give you an explanation. Math doesn't always make sense. Just know it's an M. M means slope. Okay? And slope is what we call rise over run, or what we know as the change in Y over the change in X, or take 2 points from Y and subtract them, and take 2 points from X and subtract them. Think about a graph. Rise is your Y, run is your X, okay? So it's the change in Y over the change in X, all right? Sorry, I accidentally muted myself. Okay, I want a new whiteboard. Thank you, new whiteboard. Okay, back to this. So we use this formula, M equals Y2 minus Y1 over X2 minus X1, where these are just a set of Y points, and these are just a set of X points. Now we know we don't get them when we get a set of points. It's not X and X, it's X and Y. So if I had these 2 points, we know they're X and Y, and I wanted to know the slope. Now the reason why I can find the slope is because if I were to graph these 2 points and connect them, I'd have a line, correct? And we're finding the slope of a line. So, let's see. Positive 2, negative 1 would be right there, and negative 5, positive 3 would be up here. Now we could connect these and we'd have a straight line. But I need to know, what is its slope? What is its rise over run? Meaning if I were to go from this point, how far up would I have to go up, and how far over would I have to go to get to that point? This is what we call the slope, the rise over the run. So all you do, these are our first set of points, these are our second set of points. It doesn't matter which ones. You could make these ones your first and these ones your second. Doesn't matter. But we're going to fill in this formula. So Y2 minus Y1 over X2 minus X1. Take a second and look at where I got those from. I used the formula, and I got them from our 2 points. Now we know 2 negatives make a positive, so 3 plus 1 gives you 4, and 2 negatives added together gives you a 7. So your slope is negative 4/7. You'd have to go up 4 and run over 7 to get here. And the reason why it's negative is because look at what way we're going. We're going to the negative side of the X. Okay, also, another way to know it's negative, another way to think about it is when you're looking at your line. This line is going down. Remember, we read right from left. So if you read right from left, this line is going down. It has a negative slope. If I had a line going the other way, reading right from left, it's going up, it would have a positive slope. All right, let's try another one. Let's try another one. What if I had the 2 points, 5 3, and negative 2, negative 1. And I needed to find a slope. All right. This is an x, this is a y, this is an x, this is a y. Let's make these my first ones and these my second ones, because it doesn't matter. Slope is the change in y over the change in x. We're going to fill them out. y2 minus y1 over x2 minus x1. Oh, I just used the same numbers. That wasn't smart. Well, that's all right. I switched them. Okay. So this gives you 4, and this gives you negative 7. Let's try another one, though. I want you to use other numbers. How about we use, let's use 8, 3, and negative 2, negative 2. Okay? Here you have an x and a y, and an x and a y. These are my first ones. These are my second ones. And slope is y2 minus y1 over x2 minus x1. So we're going to fill it out. y2 minus y1 over x2 minus x1. Negative 2 minus 3 gives you negative 5. And negative 2 minus negative 8 gives you negative 10. And what do you know if you have two negatives? Makes a positive. And 5/10 reduces down to 1/2. So there's your slope. And if you were to graph these 2 points to get from one part of the line to another part of the line, you would just have to go up 1 and over 2. That's what this is saying. Change in y, up and down is 1. Change in x, right to left is 2. All right. Let's take it a little bit farther. What if I wanted you to find the slope, but I don't give you 2 points, I give you the equation of the line. That is an equation of the line. Remember, when you have an x and a y, that represents a line. Because there's so many points, there's an infinite amount of points that would work. We have to graph it to show all of the points. All right, well, do you remember to find the x-intercept, you make y equal to 0 and solve, and to find the y-intercept, you make x equal to 0 and solve? We can actually get 2 points out of here just by looking for the x and y-intercept. So if I make y equal to 0, I get 4x minus 0 equals negative 8. So that's just 4x equals negative 8. Divide by 4, and I get x is negative 2. So I know that the x-intercept is negative 2. Now if I make x 0, I have 4 times 0 minus y equals negative 8. So 0 minus y equals negative 8. So I'm stuck with negative y equals negative 8, and you know you can't have that negative, so you divide out the negative 1, and you get y is 8. So when x is 0, y is 8. Now I have my 2 points, x and y, x and y, first one, second one. So using that formula, I'm going to find the slope. y2 minus y1 over x2 minus x1. What do I get? I get 8 over, 2 negatives make a positive, 2, which is 4 over 1. Now, you can say it's just 4, but when we deal with slope, slope always has to be a fraction. So if it's a whole number, you put it over 1. So the slope is 4 over 1. We used an equation, found the y and x intercepts, and used those numbers to find the slope. Okay. What about if the equation looked like this? What if the equation was y equals 2 or x plus 1 equals 0? And remember, these were special kinds of lines. If it only has a y, that means on the graph, it would go through 2 on the y, so it is a horizontal line. And on here, of course, we'd move the 1 over, and we get x equals -1. This one only has an x, goes through -1. Of course, if I could draw it better, there you go. We'll just make the point bigger. That is the vertical line. Now remember, those are our two exceptions. Those are our two special types of lines. Well, with horizontal lines, slope is what you have to figure. If it's a line going this way, you're rising over running up. If it's a line going this way, you're rising over running going down. And if it's a horizontal line, you're actually going nowhere. You just keep, so the specialty is that the slope is 0 when it's a horizontal line. Now, for the vertical, you may be rising, but you're not running. So if you try to walk, you're going to fall down. This is my way of remembering. So if you fall down, you hurt yourself, you go splat, and you are what we call undefined. So positively walking up slope, negatively walking down slope, getting nowhere, 0, and trying to walk and falling down splat, undefined. So you need to remember, for a horizontal line, the slope is always 0. For a vertical line, the slope is always undefined. Everything else either has a positive or a negative slope. Okay? All right. Now, they want you to know a particular formula, which is the formula for a line, and it's called the slope-intercept form. And to be more specific, it's the y-intercept form. This right here you recognize is the slope, it's the m. This right here is a b, the letter b, and it represents the y-intercept. Now remember, what was the y-intercept? That's when x is 0, and it's where it crosses the y-axis, but the x number is always 0, okay? So if I had something that looked like this, y equals 3x minus 4, and I wanted you to find the slope, found it, slope is 3. If I had y equals -1/2 x minus 3, what's the slope? Found it, slope is -1/2. What if I had 3x minus 5y equals 8? Can't just find it, but can you solve for y, meaning isolate this variable, and then it would be in this formula right here, and we'd be able to solve and find the slope. So in this case, my x's need to move over. -5y equals -3x plus 8. And I need to divide out the -5. I just have to have y equals. Now, 2 negatives make a positive, and 3 over 5 is just 3 over 5. A positive and a negative make a negative, and you can leave it in fraction form. I took the equation, I solved for y. Now can I find the slope? Found it. The slope is 3/5. So even if they give you it in an equation form, you don't always have to just find the x and y intercepts like I did before. If you can put it into this formula, you can find the slope. All right, one more thing that they want you to know. One more thing. They want you to know that parallel lines all have the same slope. Perpendicular lines have what we call inverted and opposite slopes. All right, let's look at what this means. First of all, if I have parallel lines, that means I'm going to have two things. I could have I have to have two lines. So say y equals 1/2 x minus 3 and y equals 1/2 x plus 5. Whatever you do, these are parallel lines. If you put them on the graph, they'd be parallel lines because their slopes are the same. Now, if I had y equals 1/3 x minus 8 and y equals negative 3x plus 5, these are perpendicular. Now let's look why. What did I say they had to have? Inverted and opposite. First of all, opposite means one positive, one negative. 1/3 is positive, negative 3 is negative. So I have the opposite. Inverted means this one is 1/3. This one is 3/1. There it's opposite. 1/3, 3/1. One's positive, one's negative. They are opposite and inverted. Now let's look at this. Let's look at this one. Y equals 1/2 x minus 3. What would a line have to have? What slope would it have to have if it was going to be perpendicular? Well, right now we have positive 1/2. So the perpendicular line would have to have negative 2/1 slope. Then they'd be perpendicular. Okay? Parallel lines, same slope, and notice it's a pair. You're looking at a pair. Perpendicular lines, inverted opposite slope, again a pair. And they're going to have you look at pairs, okay? So let me just show you one example of that. What if I was given this? Line 1 went through this and this, and line 2 went through this and this. Well, I'm supposed to look at the slopes. To determine if these lines are parallel or perpendicular, I have to look at the slopes. Well, what did we just work on? How do you look at slopes when you're given points? x1, y1, x2, y2. Slope is equal to y2 minus y1 over x2 minus x1. So we get 5 minus 1 is 4. 4 plus 2 is 6, or 2/3. Okay? Again, x1, y1, x2, y2. Line 1 slope was 2/3. Let's see what line 2 slope is. y2 minus y1 over x2 minus x1. Negative 2 minus 0 is negative 2, and 0 minus 3 is negative 3. What do two negatives make? A positive. Are they the same slope? Yep. So they are parallel. Or they could do it this way. Line 1 is 2y equals 3x minus 6, and line 2 is 2x plus 3y equals negative 6. Are they parallel? Are they perpendicular? I don't know. I have to see the slopes. How do you find a slope when it's in an equation form? You put it in y equals mx plus b. Here's my y. It's already isolated. I only have to divide out the 2. So I get y equals 3/2 x minus 3. Here, I have to isolate my y. So I need to move my 2x over. I get 3y equals negative 2x minus 6. I divide by 3, and I get y equals negative 2/3 x minus 2. Look at the slopes. They're not the same. They're opposite. One's positive, one's negative, and they're inverted. One's 3/2, one's 2/3. So these lines are perpendicular by comparing slopes. Now that's a lot. There you go. Sorry, I muted myself. Now that was a lot for 3.2. So I'm going to stop here because I think you're going to need to stop, pause, work on stuff, come back. There's a lot of information in 3.2. But everything in 3.2 we build upon, so we need to make sure that you get 3.2 solidly. So you go through and practice all those things, okay? All right, and I will see you later. Stop recording.